In hydraulic lift, 620 Newton force is exerted on a 0.2 meter square piston in order to support a weight that is placed on a 2 meter square piston. How much pressure is exerted on the narrow piston? How much weight can the wide piston lift? And what mass can the wide piston lift? Okay, so I'm going to separate the questions. Okay, so it's asking me to find pressure in the narrow piston, the weight that it can lift, and the mass that that weight represents. So a hydraulic lift looks very similar to the one I put over there. And the idea in the exercise, it doesn't have, it's not about a car. I put the car because that's the image I found, but it's not about a car specifically. Okay, so the first thing that we need to do is we need to gather the information from the word problem. Okay, so okay, first I know that it's about hydraulic lift. That's the kind of exercises that this problem about. Now, we need to understand that in a hydraulic lift, we're going to have two different areas, the smaller area and the larger area. So I'm going to call those areas like A and B, okay? Being A, the small area, and being B, the larger area, okay? Now, I will put all the information possible in the hydraulic lift, okay? I will organize all the information possible right here. So, what do I know about this small area? What information I can put there? Let's see. The problem tells you that a force of 620 Newton is exerted on the 0.2 square meter piston. Okay, so what piston do you think is this? The piston A or the piston B?
Piston A.
The piston A, so I'm going to put that information over here. 0.2 square meters. Okay, this is the area of the side A. Now, the force, where is the force being applied? In the piston A or in the piston B?
In the piston A.
Well, it says in our problem, it says that is applied, is exerted on that piston. So in the smaller piston, I will put the force of 620 newtons. That the exercise is talking to you about. Okay, so that you can call it as force applied in A. Now, what do I know about the second piston? What do I know about the second piston?
Its weight is 2.0 meters square.
Okay, so I know the area, and the area is 2.0 meters square or square meters. You can just put the 2 square meters and that will be okay. Except now it looks better. Well, I couldn't. It's gonna be like that. Okay, so now I have gathered all the possible information and now I'm gonna focus on the questions. The first one, it says, how much pressure is exerted on the narrow piston. So the first question, I need to find pressure. Where? On the narrow piston. So I'm going to work in that part. Pressure. By Pascal's principle, I know that pressure is equal to the force divided by the area. That is the equation that we're going to be using to calculate pressure. But because it says the narrow piston, I will include the information only from the narrow piston. The narrow piston is located in the position A. So I will divide the force applied in A by the area of the piston A. I will substitute by the data that I have. The force applied in A, that is 620 Newton, divided by the area in A, that is the narrow piston, there is 0.2 meters squared. When you do this division, what is the answer that you get? What is the answer that you get?
3,100.
3,100. Now take a look at the units. I have Newton because we're talking about force. And I have meter squared because I'm talking also about area. So the units are Newton per meter squared. But in physics, instead of writing Newton per meter squared, every time you divide Newton per square meters, what you're going to get instead is Pascal. Pascal is the unit that we use to express pressure, okay? So 1 Pascal is equal to 1 Newton over square meter, okay? Remember this. So every time you have those two units exactly like that, Newton and meter square, we're going to be talking about pascals. And with this, we answered the first question. Now I will continue with the question number 2. It says, how much weight can the wide piston lift? So I'm asking you to find weight. And weight where? It says the wide piston, okay? So the wide piston refers to the position B, okay? Because there is where I have the larger piston in the position B. So in part number 2, I will get the weight. Now, what is the weight? Is weight volume? Is weight force? Is weight pressure? Is weight mass? What is weight?
Mass.
Weight is related to a mass, but if the weight was mass, it will be measured in kilograms, and it's not measured in kilograms. So what is weight?
Volume.
No, because volume, we measure volume in liters, cubic meters, milliliters, okay? In what units do we measure the weight?
Pressure.
No.
In Pascal.
This is the first time that we see pressure. We haven't used unit pressures before, okay? Okay, what is the equation for weight? Weight is equal to what? Mass times gravity, okay? Mass times gravity. Mass is measured in kilograms. Gravity is measured in meters over seconds squared. But in the end, weight is measured in what units?
Newtons.
Newton, okay? Newton is the way that we measure the weight. Now, Newton is a unit for what? Pressure, force, area, volume, for what?
Force.
Force.
Okay, so with Newton, we measure force. That is correct. So weight, in other words, is another example of force. So even though the problem is asking you to find the weight, in other words, asking you to find force. And remember, pressure relates force and area. So what we should do is we're going to be applying the Pascal's principle. Pascal's principle says that the pressure, the force is going to be transmitted equally in every part inside the container. In other words, the pressure in this point is going to be exactly the same as the pressure in the other point. So if I want to transmit this or to write this into equation, that will be the pressure in the point A is going to be the same pressure in the point B. What is the equation for pressure? Force divided by the area. So the force in A divided by the area in A equals to the force in B divided by the area in B. Now, this, we already got it from the step before, okay? From here. Force A divided by area A, okay? So you can skip this step and you can just write directly the formula, okay, the result. 3,100 pascals is going to be equal to the other side of the formula. That is the force B. Remember that force, we're talking about the weight that the hydraulic lift can lift. And this is going to be divided by the area in B. The force in B that is the unknown, that's what I want to find. And the area in B that is 2 square meters. To isolate, just put it over there from division to multiplication. So this is going to be 2 times 3,100 is going to give you 6,200. And because I'm looking for force, this is going to be given in newtons. So the way that it can lift is 6,200 newton. Like that.